Thank you.
The floor is yours.
You will be happy to know that I only have a few slides, so it's not going to take that long. But I wanted to bring you back from the labs to the boots on the ground, to the beach. We are looking from the response perspective side of things, and you might want to ask why oil spill response. I'm representing oil spill response, why we are involved in plastic spills. And that's something that we actually did. We did respond to the spill in Sri Lanka, and that's where majority of our knowledge comes from. And this presentation is focusing very much on what effects and what impacts would it have on the response and shoreline surveys in particular, but also wider consideration of plastic pellets for response altogether. You might know that Oil Spill Response is the largest industry cooperative. It's for oil spills, as I mentioned, responding to oil spills, but because our members are dealing with other substances at the moment, so plastics kind of came to us, and we did it because that's one of our members or one of our clients that called us. So starting with the source. So benchmark of the industry is SCAT, which is the shoreline cleanup assessment technique. And that's something that oil responders know. They use it all the time. It's pretty much the benchmark for everything. And it's built up of these key principles that you can see there on the screen. But the whole point of the shoreline cleanup assessment is to be able to assess what is the best technique for the environment that you're working with. And it's a very efficient, a very good method, and it allows you to make decisions quickly based on the data that is all done in the same way. So you will have the assessment of shorelines. So you will look at different aspects such as the shoreline type, the oiling, the character of the pollution, and you will make decisions based on that. You will then look at division of the coastline into segments, and that's done based on the uniform, the sediment type and the uniform environment that is in this particular segment. And the reason why we do this, because we know that the response will look very different if you have sand on the beach, or it would look very different if you have a lot of debris, or if it's just a normal sediment, is grass, or if it's just a riprap or a rocky shoreline. So it will look very different. We use standard set of terms and definitions, and that's very good because we all know what we are talking about if we talk about certain sediment type or an exposed rocky shore or unexposed or other. So it's very good because we all speak the same language. You have the SCAT team, which is crucial part in here because they're all trained. They know what they're doing. So you can just send your team and say, this is your segment, please bring me the assessment back. And then I can use it to inform my instant command team to make decisions on the cleanup. And as I mentioned, it's the timely provision of data and information for decision-making. And that's the most important about SCAT. It gives us information that we need to be able to make decisions, the right decisions about the cleanup. And you can see there on the right bottom side of the slide is the SCAT field guide that we use. And it's freely available, so you can download it from the website if you would like to know more. So how does this look now for plastic? So we, obviously, when we were called there, we were using the knowledge that we already have, and it's a great benchmark to use for the plastic spills as well. So we took it and we thought, okay, we can adapt it to the situation we have to recover the nurdles or the plastic pellets. So there is some consideration though with the microplastics, and it's a lighter product. So its behavior is very different than oil. It remobilizes much faster. So you can expect that more surveys will be needed because, you know, if you would expect from an oil to appear, you will go there tomorrow and there will be more oil, but there will definitely be oil there. But with nurdles, they might not be there tomorrow. They might remobilize to somewhere else. So it's important to know that the behavior will be different. The other thing is the subsurface penetration. So again, with oil, you know, if you will see a little bit of oil, if you dig deeper down, there will be more oil coming after that. But with nurdles, there might be several pellets in here and then several pellets in here. So there will be, the distribution will be very different. You will not know if there's more pellets coming after the few pellets you found, or maybe not. So it makes the response much different. It makes it much harder because we don't know what we are dealing with, how much of the nurdles are actually there in the subsurface. There is a different appearance. So again, if you look at the Sri Lanka spill, so we had the plastic pellets which were untouched pellets as it is. There were some of them that were fused, they were burned, they came in like a clumps. So you have to know what you are looking for, because they might look differently. So that's another thing. The toxicity, as my colleagues mentioned, typically NERDOs have low toxicity, but then again, if they come from an incident, they might mix with some chemicals that can increase the toxicity. But also, if they are there for a long time, they can again come back with some of the bacteria, some of the microorganisms. So what John was mentioning about Escherichia coli, that can be something that can cause a problem. So there might be some consideration that you need to give to your teams when they go to the beach about the PPE. So that's important from the point of view of the responders as well. The quantity of recovered product, again, that's another thing that we have to look at. How are we collecting them? How much of them is there? And also the fact that we have some methods, which you can see there at the bottom is the two-minute NERDOS survey, which was adopted again from different methods that were available. And that was found to be the easiest and the most efficient way in Sri Lanka, because there was lots of NERDOS and we had to make quick decisions. We couldn't, some of the methods were there that assess 10 minutes survey, but 10 minutes, if you look at how much you have to cover, it's really long time. So it was adopted to be 2 minutes, and then you count the NERDOS that you find in 2 minutes, and then you just weigh it, and you choose your segment based on the medium pollution. So you wouldn't go to the highest concentration, but to create some kind of a baseline, you will go to a medium pollution site. But also what is important to know is that every incident will be different. So if you go to one incident and you say, this is lots of pollution, there's a lot of NERDOS, and you will say, this is my baseline to say there's a lot of NERDOS, but then you will go to a different incident and a lot of NERDOS will look very different to the other incident. So there's also the variation in this. So now coming to the discussion points. And that's something that I want to give to you to have some kind of thoughts and maybe discussion later when we get to the panel. But the consideration itself, some of the things I already mentioned, what kind of plastics are we looking at when we talk about microplastics? So we established there are pellets, we have some fibers, we have some polymeric rubbers. There is a variety of what we can look at, and the response side of things will look different for them, because we have experience with NERDOS. We know how now we can recover them, but we don't know how to recover fibers. We didn't get there yet. So there's that consideration. The other thing is about the shoreline sensitivity. So how clean we want to leave it. Because that's a very important consideration from the point of view of the response. Because with oil spills, we know that there is time when we just leave it, even if there's a little bit of oil, the environment will recover. It will be fine in some period of time. With NERDOS, it won't, because the biodegradation is very different. So then how clean we have to leave it in order for environment to still be able to work operate as normal. So that's another consideration. We then have to look at the remobilization. So again, the fact that they might move and they may come back, and then we say, okay, we close the response now, it's fine. We establish these endpoints, and then in a week's time, you have a big numbers of pellets coming back again. And then what do? Do you open up the response again? Do you bring your responders back and you start from the beginning? So that's another consideration as well. Also the baseline for the survey. So we all know, we've seen the images of how it might look like with the existing pollution, and it's not just microplastic, it's a macroplastic as well. Then do we clean it up before? Do we clean it up all together? And then waste-wise, what do we do with the waste? And also, if someone is paying for us to respond to this incident, are they going to be paying for all of this to be recovered? So, there's a lot of question there as well. And also the acute and chronic impact of NERDOS. And we talked a bit about the health impacts, but there's also a lot of research that has to be done in terms of the environment and how it can recover. And we have some data now where we can look coming back, but we need more data to understand how it actually affects the environment as well. Then the other consideration, one of the big ones there is NEBA, which is the net environmental benefit analysis. And this is the tool that we use to, again, make good decisions about which strategies we can use and what's the best way to clean up this particular environment. And with that, we have to look at the point of view of doing a cleanup, and then how much of the effort we put into this cleanup in order to have some kind of a balance with the emissions that we do at the same time, but also the impact that we have on the environment. So again, looking at the endpoints. So that's one of the considerations. Do we continue with the response, leave it as it is, because that's the benefit for the environment, or do we continue? We also look at the emerging technologies. So you can see some of the equipment, and we will look at it a bit later in the afternoon for the recovery of nurdles again. But that's something that was pretty much developed in the last few years. You know, since Sri Lanka, there was a big boom of, okay, we look at the traumas, we look at the sieves, the vacuum systems. So there isn't an established set of equipment saying, we have a plastic spill tomorrow, that's what we take and we go and we use it for response. So the technology didn't catch up yet, but also with things like starting from the source of the spill. So we were talking about the fact that you can find some plastic. Do we look at the manufacturers and put some of the duty to them to say, you have to imprint your nurdles to then we know they come from you and you can claim it, that's your responsibility. Or we can look at maybe the storage points or the way how they are being transported. You know, we worked so long to get rid of the single hull vessels. Now we have to look at, maybe we have to change the way how they are stored or how they are transported. So that's that side of things. Alignment of SCAT, alignment with SCAT again. So as I mentioned, there are some methods of quantifying the plastic, and some of the responders know it and we use it, but do you all know about it? Did you know about the 2-minute survey that I just told you about? So, you know, the dissemination of data and giving you the information that you might use to do, and make sure that we all use similar methods that are confirmed and they are good. And then again, grouping of plastics. So with oils, we have the 4 groups. It's all well established. We all use it. It's very easy. You just take the table, look at the oil and say, okay, this is the behavior. This is my information for the response. Very easy. With plastics, we don't know. Would it be different if it's the high density polyethylene, if it's because it's heavier from the polyethylene or polypropylene? Would it be different from the point of view response? Because some of them are heavier, some of them are not. But would it matter for us? We don't really know, because we didn't have a chance to find it yet. But that might be something, a consideration in the future, that there might be maybe some kind of a way of categorizing them, maybe. And then the post-spill monitoring side of things. So they, like I mentioned, they might appear a few years after the incident. And we might want to think about how we can then gather this information and how we can use it and how we can be informed in the future as well. So that's some of the discussion points, and I hope we can talk about them maybe a bit later. But the last slide is the publications. So some of the work that's been done already, and I wanted to share with you, it's not been published yet. The first 2 hasn't been published yet, is the guidelines of cleanup of plastic pellets from ship source spills, and that's based on very recent spills that has been done. This is very up to date, and I think it will be published either towards the end of the year, I think, or October, yeah. So it's an IMO guideline, so we will be able to all access it. We are also producing a cleanup field guide, so the same as the one I showed you for SCAT. There will be one for microplastics as well, again, free to access on our website. And I also wanted to point you to the direction of the plastic working group publications, because some of them Josh was already showing, but there is more, and they're a good source of information and very up to date. Well, relatively up to date now, because it's been a few years. And there's others, and I know some of the colleagues already mentioned some of them before, but that's some of them that you can, or hopefully you will be soon able to access as well. Thank you.
Marta, thank you very much. Any questions for Marta? Yes, Paul.
The 2-minute nurdle survey sounds fascinating. Is there any way you could describe it in 2 minutes?
Describe it. How would you do it? You just go to the beach. You take your PPE with you. Make sure you have your life jacket. Because you will be on the shoreline. You just look at the area, you choose the area, like I mentioned, medium coverage for the nurdles, and then you just collect the nurdles into container, take it to your scale, weigh it, you have your data. I mean, not including all the bits about the segmentation and choosing your environment, because that's going to come with the form. So there is an actual form. I forgot to mention, sorry, that's important. There is a form that you can just follow and fill up all the information that you use. The survey, or the 2-minute survey, is just for quantification, but there is a big form that, not big, it's 2-3 pages that you can fill in that will guide you the steps that you have to do. It's very straightforward, very easy.
Any other questions on that? Is there any way in the field that you can identify what sort of coating is on the nurdle that you find? Because the treatment and clearly the treatment and handling of them between different types of nurdles is critical.
I mean, it wouldn't be the thing you would do in the field, because your job is to clean up the spill.
No, okay. But how quickly can you get them analysed? Because analysis informs analysis informs remediation, doesn't it?
I know, but I would say the timescale of losing analysis, I think, isn't useful or operational.
Yeah.
So how long do you think? How long does it take to get a sample analysed?
We've seen people try to do fingerprinting in 2 years, but it never happened.
Yeah.
Or we've had people doing analysis like shown earlier, and I guess they'll get to ask you better a couple months, I presume.
Really? Yeah.
So really, the best approach is not as common up there. Just treat it all.
Well, I'm loading the questions because it's going to inform the discussion in the afternoon. Because it is really difficult. Because if you look at the presentation which John and Paul gave, and it was good to give it as the airtime that we gave it, because these nurdles are clearly attract other pollutants, and they become a sump for those other pollutants. And until you know what is in the nurdle, that does to some degree dictate the endpoint.
This would be the ideal world, but like
the
time frames that you have when you have,
and that's it. I mean, and the other bit I will come in a minute. I just want to carry this thread on a bit, because the problem is you're working when you deploy to a spill. In many cases, you're working for one of your members, and so they want an endpoint. They want an endpoint, and if you're working for a ship owner or an insurer or whatever, they're pushing for the endpoint all the time. But how can the endpoint truly be determined without the analysis of what you're recovering? So if you go to a hydrocarbon spill, you can get the analysis much more quickly.
Yeah.
The point of the hydrocarbon spill also isn't determined by lab analysis.
No,
it isn't.
Yeah. You use SCAT to drive that in hydrocarbon spill, so you can use SCAT technology to drive endpoints, not without lab analysis. Excluding lab analysis, but lab analysis can complement it.
Yeah.
So with nurdles, we can look at that. We don't have an answer. That 2 minutes.
No. We won't have we won't have answers.
The 2-minute survey was developed during the Sri Lanka spill, because it needed to be developed there and then.
Yeah.
Right.
Yeah, the 10 minutes, I think, one.
10 minutes got developed just to improve what worked.
Yeah. Robert.
Any of the studies that have been done, there's research that's shown that low levels of radiation can put the tube has made its way to Hawaii, piggyback on nurdles, on the plastics. So has there been any testing done to see whether these nurdles contain radioactive material?
No.
Paul would have to answer that. Paul.
Just think on the just going back to the laboratory analysis.
Yeah.
I think from over the laboratory side, if we could create a suite of analysis that nurdles were always tested for, and then the laboratories could quite easily set that up, So you could have a turnaround of 10 days or something like that.
Yeah.
It's this initial research which takes months and months. But,
Yeah.
but no, when we come to a stage where you have them tested for bacteria content, for KAHs, for pesticides or whatever like that, that would then become routine. The lab would set itself up, you would be off it for 10 days, whatever the lab is, it would be routine work. But at the moment, the laboratories would need that suite of testing so they can develop that throughput of work. And then the prices will go down then.
Okay, and now is there any way that we can speed up the analysis to get a rough analysis, the subject? In other words, sometime when I had my business, we developed a way of testing hydrocarbons in the field for the contamination. So we had that, and we had it in effectively a pilot handheld device, which had a clever chip in it.
Yeah, it depends what kind of analysis what kind of analyze that you're looking for.
Yeah.
So again, as technology moves along, you've got lots of handheld TPH analyzers. You've got like the hack and the colorimetric and the photometric, little handheld testers and all this lot. So again,
we had a microspectrometer which was inside it.
Exactly.
Yeah.
So again, for that kind of work, and there could be things that you can develop as handheld, and then there'll be other things like dioxins or whatever, or PCBs that will never become a handheld analysis. So.
Is that a message for me?
No,
is
that's
that saying
just
shut up? You're thinking, shut up, shut up, you're digging a hole for yourself. But no, I do actually, because I do think, I mean, the prevalence of nurdles and the harm that it is clear that they cause, and they are, and clearly they attract other pollutants to them. The radiation is a good example, and they can travel thousands and thousands of miles on the wind, on the currents, and whatever. So they can export contamination one area to another quite simply over a long period of time. And wherever they are, that nurdle is, it's emitting that pollution. It does, it will contain it, but it's also passing it on to anything that it comes in contact with. So actually, isn't there an argument that we do need, when we get the nurdle, we need to know what's harmful, what's mega harmful, and for God's sake, get it out of the ground as quickly as possible, but actually we need the technology to help us.
It is, Mark, but at the same time, you have to think about where in the whole response you are, because the responders don't need this information, but the people that will be remediating or taking the waste, they need this information.
But actually the responders also need it, because that informs their PPE and your RPE.
Yes, but
just go every standards, right?
Well, yeah, but
because if you assume that maybe it's not.
But how can you assume that every nurdle is dangerous?
How can you assume that every water's going to give you? I mean, once you know. Sorry.
I was just discussing with my colleague, one of the big challenges is also new pollution versus legacy pollution.
Yeah, indeed.
You've actually got an issue where you're looking at something that's been there 5 years. And something that's been there 5 minutes.
Yeah.
And I think this is one of the big challenges of particularly nodal collection and recovery is what are you looking at?
And the other thing is that you will collect the sample today, and tomorrow the sample might be completely different from that same location.
Richard.
Just a quick question following on from that, but timescales are obviously really important. With the Express Pearl, this was, if you like, a big experiment.
Oh yeah.
Really, we should be able to understand how this material changed, because it was an enormous one hit. Is there insight into how these changes, both physically and chemically?
So I think CFAS did some studies, but I don't think it's publicly available. Yeah, they cannot share it. I think the studies has been done, but we cannot have insight. We don't have insight into it, unfortunately.
I think
yeah, and I think this is we do need to share this information. We need to find ways of sharing this information, because it is actually affecting people's. It has the potential to affect people's lives. Marta, thank you very much for that. It was informing. And again, it like some of the other presentations, it does pose more questions than answers, but it is actually good that the questions are being answered.